Okay, so just let me share my screen. Okay, so I think it is visible.
Yeah, sure.
Okay, so last day we were discussing about different scenarios related to C and C++, and some of the variables, not only variables, some of the operators, functions, and structure of using C++. So one of such difference between C and C++ is declaration of variables. So in C you have seen the variables are normally declared at the starting of your program. Like they are declared normally in this way. Say in main when we start, and just after main we declare all the variables like this, sum, etc., and then we continue with the program. So it is, if we want to declare some variable here after some statement, it gives some error. In C it gives some error, so it is usually not done in C. So what you need to do, you need to go here at the top and to declare the variable. So say if your program is a very small program, it is good to scroll to the up and write down all these variables, or I means declare the variables. But if your program is having say 1,000 lines of code or more than 1,000 lines of code, then it is and if you want to declare a variable after say 100 line or after 500 lines, so you need to scroll up, and that is a very hectic job. So this is one disadvantage of C, you can say. So all the variables need to be defined at the beginning of the scope, but this for C++ it is not mandatory. Okay, so C also you need to remember that what all variables are declared here. Say this is after 500 lines, you want to declare one more variable, that is int a. Okay, again you are declaring int a. Maybe you forget that you have already declared it. Then also it is giving you some error. Okay, so it is very much problematic to remember how many variables you have declared at the above. Okay, so to solve this, and for C++ is having this advantage that you can declare the variables anywhere in the program before using it. That is, please switch off your microphones. So you can declare them whenever you want to use. You can declare just before the. Please switch off your microphones. So you can declare it anywhere, wherever you want to use it. Just before using it, you can declare it. Okay, and not only this declaration, flexibility of declaration. It is the C++ is also having one more means one more advantage, that it lets you initialize the variables at runtime. So this thing, this is an advantage of C++. So in C, whenever you want to initialize any variable, you need to first declare that variable, and then you need to initialize the variable with some constant. And the compiler, at the time of compilation, it will just fix the initialization, and it understands well how the initialization has been done. Okay, but in C++, there is one flexibility that both the declaration and initialization can be done at the same time. So here the variables in C++, the variables, they can be initialized at runtime using the expressions at the place of declaration. Okay, so this, if you can see this one, this is the declaration and this is the initialization, and you can combine both of them, and these type of statements are allowed in C++. So initialization and declaration both can be done at the same time and at the runtime. That's why it is known as dynamic initialization. So dynamic initialization is possible in C++, but it is not possible in C. This is one more difference between them. Okay, so this particular thing, that is a reference variable in C++, uh, we will be considering almost means in every cases we'll be considering different reference variable. So I am just discussing the basic of it, that is what it means, what it means. But Subroto Nandi sir is going to declare, means going to define this thing and discuss this thing in a very detailed manner. Okay, I'm just telling you what is it. So a reference variable actually it provides an alias or alternative name for a previously defined variable. So this is the syntax of declaring any alias name, that is a single variable total, say single variable total. Okay, it is given one more name. So sometimes in some scenarios it is very much required to have a single memory location to be pointed out by two names. So this is the variable name and this is the alias name, sorry, alias name, that is the alternative name. Okay, so the syntax of writing this kind of name or creating this kind of reference variable is, first you need to write down the data type, then address of this ampersand reference name and then the variable name. So this address of operator is actually not used here as address of operator. This is not used here as address of operator. It means it is a reference to this data type. Is a reference to this data type. So what we need to do, we can we can declare the variable and define the variable, and we can create this type of thing. So we are following the syntax, first the data type, then and, then sum equals to total. So sum and total both are now pointing to this value 100, both of them. So if you now change them, so here for cout total and for cout sum, both will print 100. And now if you do this one, total equals to, so total is a alias name and total is a variable and sum is the alias name, alternate name. So if you change the total equals to total plus 30, so this value actually 100 gets changed to 30. So if you print sum and total anything, it will give you 30. So value is single, means both are referring to the same memory location. Okay, so that is why it is known as reference variable. And if you do sum equals to 0, both sum and total will be referring, whenever you will print it, they will be giving you 0. So this is a rule with the reference variable, that it should be initialized at the time of declaration. And so this initialization of this reference variable, if you can do this, you can do this in this way, and then you can create its an alternative name. So sometimes in our program we'll be using the reference variables. So next is some of the operators that are used in C++ mostly. So one is new and delete operators. So I'm not going deep into these two operators. I'm just telling you what are the syntaxes of using them and very small meanings of them. So in C we have used malloc and calloc functions to allocate memory dynamically. So we can use either malloc or calloc, and one more function called free to free the memory in C. So similarly, in C++, rather than using malloc and calloc functions, we'll be using two operators. Okay, so this new and delete, these are two operators, and they does the same as we do with malloc, calloc, and free. Okay, so new is for creating memory locations, and delete is for creating deleting the memory location. Okay, so new is this is the syntax for new, that is we need to create one pointer variable equals to new data type. So whatever pointer we are creating, that normally pointer we used to create using the data types. So int star pointer means this is an integer type of integer pointer. And if you write down this type of thing, p equals to new int, so it this also this also blocks a memory location for an integer. Okay, so you can have this type of thing, means you can specify the value between the braces to dynamically allocate memories. So if you write down new int, so it will create an array of 25 integers in which the first element is pointed out by this p pointer p, and the other things are same. Okay, so this you can create arrays, you can create sorry, this is the notation for creating array, the second one. So this is for initializing the memory location, that is the new memory location is initialized with this value. And this is the if you write down this type of thing, data type and size, so it is creating memory array of 10 integers. Okay, and p is pointing to the first array element. So here p is pointing to this particular variable, and here p is pointing to the first array element. And the other rules like accessing the array elements by incrementing the pointer by using for loops, those things are same. Okay, similar normally. And we can also create multi-dimensional array, so the declaration is of this type. Next is I'm just quickly telling you the things. Okay, I want to start the declaration of class and how to define them. So that's why I'm quickly just showing you these things. But all these things will be discussed in detail in the class in the later lectures. Okay. So another thing is that the just the reverse thing, that is new is used to allocate the memory and delete is used to deallocate the memory. So it is used to destroy the memory, and the memory space can be reused. So this is the syntax. This is the generated from delete and this uh, pointer variable. Okay, you need to write down the pointer variable. So this is these are the two operators mainly they are used. So new is having different means several advantages over malloc. That is, in new you don't need to write down the size of operator. Okay, it automatically takes the size and it automatically returns the correct pointer. So many advantages are there of using new. So we'll be discussing those things later. And next is one more operator that is massively used in C++, that is called scope resolution operator. So the scope resolution operator look like this. 4 points. Okay, so this is the scope resolution operator. So the scope resolution means it resolves that some variable, if you write down in some blocks, it resolves that this variable belongs to which blocks. Okay, or scope means it defines the scope of any variable. So in C++, it also follows a block structured thing. That means we can divide the whole C++ code into different blocks. Okay, so if we have same variables declared in different blocks, then those variables, how to access those variables, that means you can see here I have just put one picture here. It should be the I should be small in small case. So int x equals to 10, and in the inside block 1, int x equals to 1. So whenever we want to access x, the which value will be printed or which value we need to access, we there is a confusion. Okay, so that confusion can be resolved by declaring the scope of that variable. So in C, global version of any variable, they cannot be accessed from within the inner blocks. Okay, so C++ they resolves the problem by introducing a new operator that is known as scope resolution. So four dots, four consecutive dots. This we want to give, and this is called the scope resolution operator, and uh, which is used to declare the scope of the variable. Okay, or sometimes in the global variables, we can differentiate between the global variables and local variables by using this also. So I have here discussed a very little bit of scope resolution operator, but just after this particular slide is over, I'll start with the class and object. There you can find the use of the scope resolution operator. Okay, so whenever we create classes and whenever we create objects, say if you have more than one class in your program, so that time it may happen that one particular class is having some member function, and the same member function names, same member function, similar type of member functions with same name can be found in some other class. So that time how we will be differentiating between these two functions, because the two classes they can have the function name as same. Okay, so that time the thing can be resolved. So I am just coming to, after this discussion of this, I am just discuss all these things. So this scope resolution operator along with the variable name, if you write down, then you can access the global variables. So scope resolution operator, this in C++ is used to define the function outside a class, and when we want to use a global variable but also a local variable with the same name. Okay, so if we have the global variable, just you see this example. Say I'm having this variable, this is a global variable, character C equals to A, and inside main I am having the same variable, local variable. This is local variable and variable name is same but initialized with B. Okay, so if I want to print both A and B, then we can use this scope resolution operator. So local variable, normally if we write down C, it will print the local variable, but if we write down this one, the scope C, it will show you the global one. So one more example I have included here. You just see the example. Tell me what will be the output of this example. So here this is a global variable m. Okay, and then it main I have one more m, that is 20. Next, this is the main block. Sorry, this is one block. This is the main block, this one and this one is the main block. Within this main block one more block is there. Okay, so m is 20 here and k equals to m. Again m is initialized with 30. So what will be the value of these three?
Ma'am, K will be 30, M will be like the first M will
K will
remain
be
K
same.
will be
30.
20, 20.
K will be
This
20,
is
na?
20, 20, 20. K will be
Uh,
20,
K
M
will
will be
be
30,
20.
then
K
M will
will
be again 20.
20 or 10?
Ma'am,
Uh,
10
10,
because it is the
10.
global variable.
Ma'am,
Okay, so
30, ma'am.
okay,
Yeah.
so let me show you the execution. Okay. Okay, so I think the same program I have copied here. Okay, and I'm running. So this is the output. This is the output. I think you can view my screen. So first is k is 20, then m is 30 and m is 10. So whenever we use this thing, it will actually access the global one. Okay. So for the second one, what is the value of m? You see, in because this m value is 20 here in the inner in the outer block. Okay, I'm just making it indented to make you understand. This is the inner block. This is the inner block. Okay, so we are in inner block and this is we are in outer block. So this outer block is here m is 20. Okay, so that's why for inner block k is 20, M is 30 and M is global M is 10. And for outer block, there is no value of K because K is defined inside, declared inside this block only. So M value is 20 and the global value is 10. Okay, clear? So it
Ma'am,
depends on
ma'am,
which block you are
can
in.
ma'am,
Bolo?
can I ask one thing?
Hmm.
Yes, ma'am. Ma'am, we using the scope resolution operator, we are able to access the global variable. But is there a way to access the variable where m is equals to 20, like just above the inner block? Uh, is there a way?
Just normally you are writing this one?
No, ma'am, but we are getting outside of that block. I'm saying within staying inside the inner block, we are wanting to print m equals to 20. So we want to access the variable
No,
which
no.
is
How can you access that one? You cannot access, na?
so only global variables are accessed by
Uh-huh.
the score.
If you want to, yeah, if you want to access the global variables outside, if you want to print both m equals to 20 and m equals to 30, how can
Acha,
we do? Because m gets changed, na, here. Okay,
acha.
so this
Okay.
is just a simple example of scope resolution operator. Next is this control structure. This is you know, all of you know this thing. I'm not going to discuss this thing. So there are mainly three control structure: sequence structure, selection structure, and loop structure. So sequence structure is done with these, implemented with this if else block, and so if else ladder that you know. All the rules related to if else will be same here also. And next selection structure is switch case, and loop structure you can use any of the loop, do while or for loops. Okay, so these are the things that are same as C. And there are some functions in C++. So I have listed here uh, some 5 functions. So your any program is dividing into some functions, and that is a that is a normal way of solving any problem. Okay, so in C++ also we will be having some functions. Okay, but not only it is not like that the procedure oriented programming, but in C++ also we will be having different functions to reduce the size of program or to maintain the logic of the program. Okay, so these are the 5 functions that we mostly found in C++. So first one is the main function, and next one is the methods or member function. So whenever we declare class, you'll understand what is member function. So inside class, we'll be having some functions. They are known as methods and member functions, and one special function called inline function, friend function, and virtual function. So the use of friend function and virtual function, we need to understand the class structure, as well as we need to understand the pointer and other things. So that time we can define this friend and virtual function. So for the time being, I am leaving this 4 and 5, and I am discussing these first 3. Okay, so the main function is, as you all know, this is the starting point for the execution of a program. And in C, the main does not return any value. That is the common practice, that main does not return any value. Either you can write down void main, or you can write down normal main. But in C++, the syntax of C++ is writing int main, and it must return a zero, return zero value. Okay, so return zero actually signifies there is no error in the program. So this int main, main will be returning integer, and to support that one, we need to write down inside one return zero statement. Okay, so this is a particular declaration of main, int main. And we can also have this type of declaration. So I think you know this, what is argc and argv. I have just written down this the definition of this argc and argv. Okay, so we can have both of them, but normally we preferably use this one in our examples. Okay, so this is what I am talking about, that the main must include this return zero. Okay, so return 0, this 0 means, this return value means the exit value. Okay, so
Ma'am, could you
exit value.
repeat what RC and RV stand for, ma'am? I didn't get what RC and RV stand for.
You don't know this one, argc and argv. So if you
Uh,
want to declare, okay, I'm just in C it is done, in file handling in C. Okay, I'm telling you this thing. So this declaration, this whenever you want to do run this type of thing, like this my program argument 1, argument 2, argument 3, like in the program, in the at the time of running the program, if you if you want to provide some arguments at the same time you are running the program, if you want to pass some arguments in the main. Okay, so in the other functions, like the normal functions, in normal functions what we do, we can declare the normal function and we can declare its argument list, and whenever we call the function we usually pass the arguments within that function calling, isn't it? So the same thing can be done with main also. If I want to execute or run a particular program, and at the time of running executing it, if I want to provide some arguments, so this we can do using this particular structure. So this argc, it actually tells that how many arguments can be passed. So it is a number of arguments that can be passed to the program, and argv is actually the string array, or which is called argument vector. So it is actually a one dimensional array, okay, which takes the arguments. So argc tells you how many arguments you can pass. Okay, so here it will consider this my program is actually a C program. Okay, C or C++ program. So this my program, then three arguments it is passing, so the argc value will be 4. Okay, including this one also. So number of arguments plus 1, this is a command for means executing the program. So normally we execute the program with dot a dot out dot a slash out, like these things. So this my program is actually the executable code, and these are the arguments we are passing. So this is actually done, normally done in C whenever we want to pass some command line arguments. Okay, and argument v, this is an array which takes these arguments and then it process. So during means whenever we means call main, it automatically passes these values. If you pass these values, it passes these values to main. Okay, so this is a special procedure by which you can pass values to main also. Okay, like the normal function. Okay, so usually we try to use this one, but in some special cases also we will be considering this one. Okay, this is very funny, means this is very useful and very fun to use. Okay, like you are just providing the values to main also. Okay, so if possible I'll be showing you some codes. I'll be showing you how to use that. Okay, right now I don't have any code. I'll be showing you in the next class. Okay, so next is just I am talking about that to support this integer, we need to return something. We need to return 0. So this exit value 0 means the program ran successfully and there is no error. Okay, so this is meant to be 0, not any other value. Okay, so next is the method or member functions. So in class, whenever we define any class, just after 3-4 slides, I'll be defining the class. Within the class, there are some data and some functions. So just you remember the class template or objects, like it is having some data part and it is having some functions, and these functions can access this data. So this, if this is an object or if this is an object of any class, so this is having normally this is having this structure, that is it will be having some part of data and some part of data, and some functions are there which can access this data. So by this binding, by this encapsulation, we are actually hiding the data, and we are actually creating the object by following this particular rule. So these functions within this class, these functions are known as the member functions. Okay, so member functions are means not anything special. They will be like the normal functions that till now we have used. So, and they will be following all these three rules, that for using any function we need to do these three things, that is function prototyping, function definition, and function calling. So these three things: prototyping means declaring the function, that what is the type of the function, return type of the function, type means return type of the function, then the and the okay. So this is something like that. The function prototyping is first the data type integer, then function name sum, and we are providing the argument list as int. So here we are specifying that we will be passing two integer values within this function. Okay, and we end this with this semicolon. So this is function prototyping. And program, maybe after main, in C we used to define this. So the means the difference between prototyping and definition is, in prototyping we end this statement with this one, that is we are only declaring but not defining the body of the function. But in definition we will see here there is no semicolon, there is no termination, rather we have replaced, we have write down all the things, that is what is the return type, function name, argument list, and we are writing the body of the function. So this is the body of the function. Okay, this is just an example. And inside main we used to call this function. So during calling we need to pass these values in these arguments. So in this particular example I have passed 5 and 10. So 5 is mapped to A and 10 is mapped to B, and both of them are added, and C is returned. So whenever we return N gets initialized with C. Okay, so this is the normal thing that we usually do in C. So the same thing, same rules you need to remember, and you need to use here. But the only difference is in C++ we'll be creating class, and there are related syntax of defining the functions. Okay, also related syntax of defining the data members. Okay, that I'm coming. So next is the inline function. The inline function execution of any function, this any function call, it has some step. Roughly telling, they are having these 4 or 5 steps. So first is whenever you call a function, the CPU stores the address of the function call instruction in the memory, and then it copies the arguments on the stack by push method, and then it transfers the control to the specified function. Next, the specified function code is executed by the CPU, and the pop method returns the value that is stored in the predefined memory, and controls are returned to the caller function. So these are the 5 things, simple 5 things are done. So whenever you call the function, the address of the function call is stored, and then arguments are taken. First they are pushed into stack, then CPU transfers the control, it does all the processing, and pops means the function code will be executed, and it pops the stored values, and they will be returning the means processed value, and control is returned to the caller function. So that if we consider the time required for these four, 1, 2, 3, and fifth step. So time taken for calling a function is say T1, and time taken for execution of function is say T2. So T2 is means say this one, this execution part, fourth part. Okay, so and 1, 2, 3, and 4 calling and returning. Say if I consider this is as T1 and the execution time as T2. Say I have divided this thing into. So the uh, if the program code is large, okay, program code is large and complex, that means this particular part, this four, that means execution will take time. Execution take significant time. That means much more time than the function calling and the function returning to the function. Okay, but for more small functions, T1 is often much more than T2. That means for small functions, if your function is having say 2 or 3 lines of code or 1 line of code, okay, then calling and returning will not take much time. Sorry, calling and returning will take much more time than its execution time, because it need to execute only one statement. But these all these 4 steps, 1, 2, 3, and 5, need to be done within T1. Okay, now uh, if you have say a small function, okay, but if it is called say 100 times, say one liner function, but it is called 100 times, so that time it will be a overload. Means if you have a small function, calling and returning will take much more amount of time rather than execution, so it will be an overload. So this inline function is reduced to is used to reduce the overload of time T1, that is for calling and executing sorry, for calling and returning these particular 4 steps. Okay, that the overload of this particular 4 steps for many more function call, small function calls, can be reduced using this inline function. So the trick is very simple. The trick is that if you have some small function like this one liner or two liner function, just you need to use this keyword inline. So if you use this keyword inline, so this function is expanded inline when it is called. That means that whole thing, when it is called this push this address storage, then it is the arguments are pushed into stack, the control transfer, then returning, everything can be reduced. Just what it will do, the inline function is expanded inline when it is called. So the whole code of inline function get inserted at the point of the function call. Okay, so this is the difference. So this is done by the compiler at compile time. So at the compile time, if the compiler means gets this particular keyword inline, so what it will do, it will just replace the function call with the function body. Okay, so calling overload, calling overhead will not affect the total execution time. Okay, and also if the total execution time will be also less, because this is just one liner or two liner. Okay, so it depends on if you write down something as inline, but the function body contains a large amount of instruction, then it will automatically work as a normal function. It will not act as an inline function. Okay, but the compiler takes this responsibility. If something is written inline, the compiler takes the responsibility to check that whether it can be acting as an inline function or not. That means whether the declaration can be replaced by the definition or not. Okay, so this is one small example of inline function, that is inline double cube and double a. Just we are returning this a into a into a. Okay, so we can invoke this type of thing. That means we can whenever we write down this thing cube 3.0, so this will just, this calling one will be replaced by this definition, because this is the inline function. Okay, it will not transfer the thing. So next is the inline keyword is sends a request, not a command to the compiler. The compiler may ignore this request if the function definition is too long or too complicated, and the compile the function as a normal function. Like I am telling, if your program this function body, if it is having one liner or two liner code, then the compiler understand this is a small program and this can be used as an inline function. But if you write down a very big long program with so many instructions and with complicated logics, that time it will not compile it as a inline function. It will consider it as a normal function. Okay. So here I have written down some of the situation where we cannot means the compiler cannot takes the request of inlining. Okay, so expansion is not done in this scenario. That is for some functions returning values if a loop, a switch or go to exist. Okay, and for functions not returning values if a return statement exists, that time also it will not work. If function contains static variables, and what is static variables that we are going to discuss afterwards, and if inline functions are recursive. So recursion, if there is recursion, that means again and again the same thing will be means same instruction will be executed, that time also you cannot if you use inline keyword, it will not considered the inline thing. It will just act like a normal function. Okay. So this is how this is why we should use inline function. So this inline function, they actually makes the program run faster, because the calling and function returning over it is eliminated by this. But it makes the program take up more memory, because the statements that defines the inline function are reproduced at each point where the function is called. Okay, so the amount of memory and the amount of time it requires to run a program, there is a trade-off between these two. So we need to balance between these two. Okay, that is how much memory it is taking to replace each function call with that definition, each inline function call with its function body, that time and that memory, and the total amount of time to execute the whole program, because uh, it may be possible that 100 times the function is called. Okay, so these two things having a trade-off. So this trade-off, this we need to balance between these two. We need to balance between these two particular, time and the memory, that is cost. Okay, so next is I have included a very small inline function. Just you go through it. I have just taken this thing. So I'm calling the here. This is a normal function, like normal function call they are called. Okay, so these are the two inline functions. Just it will print the values. Next is default argument. So I think sir has discussed about it, about the default arguments a little bit. I'm not sure about it. Let me just go through very fast. Okay, what is the time? Okay, already 11:50. Okay, so this default arguments, that means whenever we call a function, we can pass the arguments. Okay, so some of the arguments you can provide the default values. Okay, so default values are specified when the function is declared. The compiler looks at the prototype to see how many arguments can be passed as default. Okay, so this is one example I have written here, that is float uh, sorry float amount. Amount is the function name and float is the return type, and it is actually passing three variables. It is having three arguments: principal, period and rate. Okay, so in the declaration, if we write down this one, rate equals to 0.15. Okay, so syntactically this is correct. Okay, so this is a declaration, so it is the default value that we are passing for rate. Now in whenever you call it, if you call this thing, this amount, particular amount function with say 5007, that means this particular float principal and period is passed. So the compiler understand, okay, these two are passed and we need to consider this default value for this. But if you pass here 5007 and comma 0.10 or 0.12, then it will take that particular rate. It will not consider the default value. Okay, So sometimes it is required that we will be specifying some fixed value to some variable, that we are passing it, but we want to fix the rate at 0.15%, 0.15%. Okay, so something like that. So that time it is we can do it by using these default variables. Now there are certain rules related to it. Okay, so this I'm telling about. If you are writing 0.12, so explicitly we are passing the value. So this value will be overloaded. This value will be overwritten by this 0.15. So that time 0.15 will not be considered. If you are passing something, if you are passing for principal, period and rate, then it will not consider this one. Otherwise, by default, it will consider this one. So that is the meaning of default argument. Okay, so it is actually it is letting the function to specify some arguments. Okay, uh, during the time of its declaration. So the rule related to default setting the default values is only the trailing arguments can have default values. So this particular part, this particular thing, so this we can do, sorry, this we can do, this is legal actually, this is not illegal, this is legal. And this one, that means the left one and the right one, but the middle one is not written anything, not initialized with anything, this is illegal. And this is also illegal, and this is also okay. So default arguments, they are useful in some situation where we want to fix the values of some arguments. So just I have written this program. So let me.
Ma'am, could you just explain why this third one is illegal, ma'am? Because, uh, like, if you went to that example now, it's given that.
Wait. I'm waiting. Going back. I'm going back. This one, na? This one you are telling, na?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Okay. Just a second.
And int I equal to 5 int j, that one.
Yeah. I got it. Just wait. I'm telling.
Okay.
I made some mistake. That's why I'm talking about. This first one and the last one is not illegal. This is legal. I was copying this thing, so I think I have copied this thing. I forget to delete this too. So this thing is legal. This thing is legal because these are the trailing. So from here to here we can change. From this side to this side we can change. But from this side to this side we cannot change. From left to right we cannot change. But from right to left we can change, because this is permissible. This is also permissible. This is also permissible. So this is legal. This is legal and this is legal, but these two are illegal. Okay, that is my mistake, my typing mistake. Okay.
Ma'am, but in the third one, ma'am, but in the third one,
Ha.
j is
Third
a
one.
trailing argument,
Ha.
and j is not initialized.
Ha.
So why is it illegal?
This is the trailing argument. Only the trailing argument can have values from this side to this side. That means from right, only at those are at the trailing that you can initialize. But this you left that you have not initialized with any default value, but this you are initializing, so it will give you some error. That's why it is illegal. I have written now only the trailing arguments can have default values. Trailing means the end arguments. If you have 5 arguments, the fifth one is the trail. Then fifth, fourth, 3, 2, 1. In that manner, you can have values. Means you can have the fifth one, the fourth one, the third one. Okay. But you cannot have like this fifth one, then the third one, then the first one. You cannot have like this. So if you have
The
two
arguments
arguments,
need to be contiguous, like the default arguments.
the default arguments need to be contiguous from the trailing side, from
Ha.
from the trailing side, not from the from right to left. Sorry, from left to right. They
Yes.
cannot be in that manner. But here in this situation, all are having default value, so it makes no sense actually. But this thing you can see, this thing is not sorry, this thing is permissible. But if I write this one, the same thing, if I write this, sorry, If I write, wait. Okay, if I write this one, say this one. This is not true. This is illegal. Means we are changing the value from this side to this side. This is illegal. Okay, you get my point. Why this is illegal? We can change j. We can have default value for j, but we cannot have default value for I here. Okay, you understand this thing? Hello? Hello?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yeah. Now you get my point. So whenever we make something default, we can make these things default from the trailing side to this side, but we cannot make them default from this side to this side. Okay. So just I have listed one example. So this is the example. I just want to print the default some of the characters. You see, I have used some default values here. For R here, this one is a default value, and for character and for length, I have used this one. So let me run it. Yeah, this is the output. So it's not coming. It must print this character. I don't know why it is not. Yeah, actually, if you print this one, if you call println and print line without anything, because in print line we are passing this. If you are again we run it. Yeah, this is what I want to show you. Actually, the line with the star, you can see the line 40 character 40 stars are printed. So first here, whenever I call this print line, I have not passed anything, and here after writing the final value, I am passing I am calling the print line with this assignment sign. Okay, so with this equals to sign. So here it is taking this equals, it is just not taking this star. In place of that, it is just overwriting the star with this value, and as we have not specified the length value here, so it is not taking the length. Okay, sorry, it is taking only 40. The same thing, same value it returns. Okay, now if let us check whether it prints something else. If I pass it with 50, yeah, so it is printing. Let me do this thing. New line. So now you got my point. What is the difference between default value and normal explicit value that we are passing? So here I am passing equals to sign. Here I am passing this sign and this sign. So these both are the same. So let me pass any other sign, say this sign. So now you see what is the output. So for the first one, it is taking the default star value and length equals to 40 value. Okay. For the second, for the second print line, execution of print line, it overrides this star value with this equals to 1, because I have explicitly passing equals to as an argument and not specifying the length. And here I am specifying the length as well as the character. Taking star, it is not taking 40 as default. It is taking my value. So when the user passes his or her own value, that time those values will be considered. The default values will not be considered then. So that is my point that I want to tell you. Okay. And the question was, if I do this thing, but not this thing. This is the question. If I have this thing, but not this thing, whether it will give you some error or not. So just run it. See, it is giving some error. Okay. So it is what it is writing, default argument missing for parameter 2. So either you need to, for 2 parameters, either you need to put some default value here. You means if you want to use this thing, you need to put some default value here. Otherwise you remove this thing. Otherwise you remove this thing and it will work fine. It will work fine. But this time this will not work because it is not passing anything. You need to pass the value. This time only this will work. This print line. Got my point? So whether whenever you are putting the default arguments, you can put from left, from right to left, but only this left is there, but right is not having default value. It is not permissible. Okay. So this is why it is this one is legal, but this one is illegal. And this one that you are mentioning, this one is also illegal. To have this I equals to 5, you need to at least have some value for j. Otherwise, it won't work. Okay. So this is the thing. And next is which I'm not going to discuss this thing. And for function overloading, there are so many things to be discussed for function overloading. Just I am telling you the difference, the meaning of function overloading. That is with this example I'm telling you. Okay, that is function can have multiple functions can have same name, but they differ in terms of the number of arguments, the type of arguments, and the order in which they are passing these arguments. Okay, so based on that, the compiler will be matching the prototype, the declaration with the calling. Okay, so how you are declaring, and that is what whenever you are declaring what is the data type, then function name is same for all. You can see this add function is same, but for prototype 1 it is returning int. For prototype 1 and prototype 2 it is returning int, but the difference is prototype 1 is having passing 2 arguments and prototype 2 is passing 3 arguments. Similarly, prototype 3 is passing 2 arguments but double arguments, and it is also returning a double. And here also it is also returning a double. It is they become same. Int and double. Should be int and double. Yeah. So this is prototype. So here I am passing int first, then double. Okay. So int and double. So here you see this one. This one is calling prototype 1. Simply we are matching, but there are rules related to these matches. Okay. there are 4 or 5 rules related to this, how we should do the match. I'm not discussing the function overloading. It will be discussed later in a very detailed manner. Okay, so there are rules. I'm not going to discuss the rules, but just simply by viewing you can see this int should match, this int this should match, or in this manner it will work. Okay, so I think I have made some mistake for prototype. Yeah, no, no. Prototype 2, this is 3 ints, and a prototype, there is no prototype 5. So this is double. Yes, prototype 3 is double, and this is integer and double. Okay, so if we have this, say this is one prototype, say integer, no, say double add, say double a int b int c double d, in this manner. If this is a prototype, then so this can be a say this type of thing. Okay, so it depends on how which order you are passing the values, and based on that it will match the prototype. Okay, but again I am telling, for matching there are rules. For matching there are rules related to this conversion. That means if there is integer and if there is float and double, so which to consider. Okay, there are upgradation and degradation also, so there are some rules. Okay, so there is one rule like data types that are narrower. Okay, they are converted, so there are the compiler automatically converts some data type to some. Okay, so there are some implicit conversions, not explicit, like we are not converting, but the compiler itself converting during the match. Okay, and there are certain rules related to these. Whenever they convert, there are certain rules related, means by which they can break the tie if there are more than one option. For a function call, if there are more than one option, there are rules to break the tie. Okay, so I'm not discussing this thing, just I am showing you one more example here. It's very small example. Just I have passed here one integer and here 2 integers with the same function name area. Okay, so I'm having some programs listed in a doc file. I'll be sharing those programs with you. All these programs don't have any class declaration, any member function definition. So I'll be sharing those programs and you just go through it. You'll be getting different C programs solved by C++, and once again you can revise the logic of these programs. Okay. So today I am stopping here, but I'll start. Let me just show you this thing. I'll start. Yeah, I'll start from here next week. I'll be starting from here. I'll be showing you what is the difference between the structure and class. And as I discussed, this is the class declaration that I'll discuss. Okay, so why this class declaration is like this, and how to expand the declaration. Okay, what are the different, what are the ways of expanding the declarations, function declarations, and why, what is this private, public, all these things in details I'll be discussing with some examples. Okay, so I'm having class on Monday 4:30, isn't it?
Yes, ma'am.
Yes, ma'am.
Okay. So if you have any query,